We are going to start a new chapter. We started it yesterday, before yesterday, and the chapter was magnetic effect of electric current. So what we studied, I'm just revising what we studied. We studied that this is a circuit, and in this circuit you can see that this is positive terminal and this is negative terminal, and usually a circuit have uh, this is battery. Okay, you have seen what is battery on last class. Okay, this is ammeter. It measures current. You know what is current? The flow of electron is known as current. This is resistance. Resistance is a thing which inhibits the passage of current. And we studied about this compass. So we studied two things, that in this compass, in this circuit, this is a circuit. Okay, in this circuit, when we start electricity, and this is especially copper wire. Okay, this is copper wire. Now what does it mean that this is copper wire and this is something else? Whole circuit is made up of wire, but generally we know that wires are covered with insulator. Okay, this is wire, and this wire is made up of a metal. It is generally copper metal in our households, and it is coated with an insulator. If you have seen this wire, so it is coated with insulator, and this is insulator is made up of plastic most probably. Okay, so metal is very good conductor and plastic is insulator. We studied this. Okay, so in this case definitely electricity can pass only by metal, so we can consider that this is a wire and it is having copper inside. So outside it is having plastic and inside it is having metallic part. Okay, now here the external part which is made up of plastic is removed, and this part you can see it is different in color. It is totally made up of copper. So this part, this extensions, you can see it is brown in color. It is metallic part, and maybe another coating of plastic has been removed, or special copper wire is added, but definitely this part is some insulator, which insulator wire which is coated with plastic from outside and metal with from inside. Definitely that's why this is, it is conducting electricity, because it is not possible for an insulator to conduct electricity. So inside there is metal wire, and here maybe the plastic cover is removed, or maybe new copper wire is added. So this is copper wire, how it looks like. This is copper wire, and it is very 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 good uh, conductor. Okay, so we studied two things. Okay, now we opened the circuit and we started to flow electricity. So we studied two things in this. What did we studied? We studied that this thing. Okay, that if it is positive side and it is negative side, so the flow of current is always from positive to negative. Okay, so in this case, if the current will flow here like here, or if the current will flow like here, you can see the needle of compass is deflected toward this side. Okay, and here this is positive side and this is negative side. So we know that the movement of current is like here. So here the movement of current is in this direction, and here the movement of current is this direction. And here you can see easily the needle of compass deflected here. So when the direction of current is here, the needle of compass deflected towards this side, and when the movement of direction is towards here, the needle of compass is deflected towards this side, because we know that electricity moves from positive to negative. So this is how we can say that each and every time when we change the direction of current, when we change the direction of current, okay, the needle of compass deflected according to the direction, yeah, or we can say changed direction of the current. Okay, so we can see this easily. So here look at this. This is more reliability diagram. This is positive, this is negative. So definitely it will flow like here, and the needle is showing this side. Okay, this is needle and this is showing this side. You can see this is the needle and it is showing this side. This needle, it is showing this side. Okay, and here it is positive and it is negative, so the movement of current will be like here, and needle is showing this side. Okay, so in this case the current will move here. Okay, it will move here, and needle is in this direction, and in this side the movement of current is upwards because it is upwards, so the direction of needle is this side. Okay, both cases. So why this needle get deflected in different direction? Our question is that why this needle get deflected in different sides? Why needle get deflected in different directions? Okay, now if you ask with the question, I will tell you that how to find the uh, electric field after this class or tomorrow. So in this case this is the direction of deflection, and this case this is the direction of deflection. So one thing is very clear to us, that needle is getting deflected in different direction because same time we are changing the direction of current. So as we are changing the direction of current, you can see this easily. One, the direction of current is here, positive to negative. The deflection is here. This is more elaborated diagram because it is having compass. And when we are having direction like this is the direction of current. Then the deflection is here. We can see easily. So the same question you could be asked. So you have to write only one thing. And after this class or after some topics, I will tell you how to recognize the magnetic field, direction of magnetic field. So the needle get deflected in different directions by changing the direction of current. Whenever you change the direction of current, the deflection of needle will definitely change. So this is the answer of this question. Okay, now the question arises, first of all we are writing magnetic effect of electric current. Okay, now what is this magnetic effect of electric current? Okay, now the question arises, the question says that this is he's a scientist, his name is Hans Christian Ørsted. Okay, this is from our NCRT. So he was the scientist, and what happened suddenly, that Hans Christian Ørsted, when once he was a leading scientist, and he played very crucial role in understanding of electromagnetism, because we are studying magnetic effect of electric current. Now what is this? Look, this is a simple circuit. Okay, this is, we know that this is our simple circuit, this is our simple circuit. Okay, now this circuit is conducting electricity. Okay, now this is conducting electricity. This is my circuit, and this circuit is simply conducting electricity. Okay, this circuit is conducting electricity. So this wire, maybe this wire is copper wire, or I must say a wire which is not coated with insulator. Okay, I can say open metal. Okay, so definitely electricity is conducting by this way, because this is positive, this is negative. So whenever you put some part which is known as iron or whatever metal you use, okay, sometimes it is better to say iron. Or so if we use iron flakes, and if we put iron flakes near this open metal wire, okay, because it is clear metal, not coated with any insulator. So if we put iron near this copper wire, okay, and electricity is conducting, what happen, that this iron flakes or this iron will get attracted towards this wire, this copper wire or open metal wire. Okay, so iron get attracted to another metal, that is copper. How is it possible? Iron is a metal, and this open copper wire is also a metal. And when there is no electricity, there is no attraction. That is clear. Okay, when there is no electricity, there is no attraction. But as soon as I conduct electricity, or I want to, I switch this cell. Okay, you know, this is our key. This is our key. So I can open key or I can close key. Okay, as when there is no electricity, the circuit is closed. There is no attraction. But when there is electricity, the question is that this copper wire, which is metal wire, is attracting this iron flux. How it is possible that one metal is attracting another metal? One metal is attracting another metal. Isn't it amazing that one metal is attracting another metal? But one metal is attracting another metal only when there is a passage of current or electricity. So definitely the passage of current or electricity brings something into this wire. This passage of electricity is bringing something into this copper wire, this metal wire. That's why it can attract this iron. Okay, so the question is that a property of attracting small iron pieces is magnetism. Okay, magnetism means, we have seen there are so many type of magnets. Okay, you can see there are so many type of magnets. Some magnets I'm going to show you. Okay, this is our normal magnet. It is known as horseshoe magnet because it looks like horseshoe. Okay, and it is having two pole, north pole and south pole. Don't consider my drawing, don't be judgmental about my drawing, because sometimes it is very difficult to write digitally. And this is bar magnet. It is having north pole and south pole. So this is our magnets. Okay, now these magnets can attract iron. Okay, I just put some iron flakes and this iron flakes will get attracted by these magnets. Okay, it is okay. But if I'm using a simple circuit, I'm using a very simple circuit, and I'm just conducting electricity. Okay, so current is passing positive to negative. Current always flow from positive to negative. And if I put some iron flakes, definitely, or I'm putting iron flakes here. Okay, and this is my copper wire. So this copper wire is attracting these iron nails or iron flakes. One metal is attracting another metal. Only when there is a passage of electricity. Okay, now in this case, when a magnet is attracting iron, it is known as magnetism. Why? So because magnets having something which can attract iron. So when magnet is attracting iron, it is known as magnetism. Okay, so the answer, or we can say, we can conclude that anything which can attract iron is known as magnetism. Anything which can attract iron is known as magnetism. Anything which can attract iron, this property is known as magnetism. Okay, so now this copper metal part is attracting iron when electricity is passing. Definitely electricity is passing, so one metal is attracting another metal, or copper wire is attracting iron. So this copper is attaining, or copper is having magnetism. So just like another magnets, because they have magnetism, they can attract iron. Our normal copper wire, which when we pass electricity from this wire, it can also attract iron. So definitely it is getting a capacity which is known as magnetism to attract iron. Okay, so this is something artificial, yes, but definitely it is also known as magnetism. So what really happened, that the scientist known as Asted, okay, this happens accidentally. Okay, this electric magnetism. What is electric magnetism? This magnetism doesn't need electricity. Does it need? that there is any need of electricity. It can attract, this magnet can attract iron without electricity, without need of any electricity. But this case, in this case we need electricity. Okay, and by conducting electricity, by passing electricity, this copper wire is getting something which is known as magnetism. That's why it can attract iron. This is very simple question. So the magnetism which is created by electricity, the magnetism which is created by electricity or gained by electricity or produced by electricity, can't we say this electromagnetism? We can say this electromagnetism. And we are studying magnetic effects of electric current, because when electric current passes from a metal, when electric current passes from a metal, this metal converts to magnet. Okay, this is our current plus metal. Okay, better if you use copper because it is having very good conductivity. So current plus metal equals to, or electricity plus electricity plus metal is equals to electromagnet or electromagnetism. And we will study its effects. Okay, what effects it cause. Okay, so the electromagnetism doesn't appeared by so many hard work. It was just a random chance, and we can say this thing appeared in nature by chance. Okay, that means he was not supposing to do something, he was not doing any experiment for this. It was a random, it was by chance, it was by luck that he discovered electromagnetism. So what he found that accidentally, okay, accidentally, he was not supposing to do this, or he was not doing anything for this, it was accidental case. He accidentally discovered this thing, that copper, that compass needle got deflected when electric current passed through metallic wire placed nearby. Okay, so this thing repeated. Okay, this thing we studied, this thing, and this thing repeated, that he was doing something else, and compass, this was a circuit, this was a circuit, he was definitely doing something else, and this was a circuit. Okay, and a compass was uh, residing nearby. Okay, and suddenly when he started current in this wire, okay, the needle of compass which was in this direction before, it was get deflected in this direction after conduction of current, or just after he started or completed the circuit or opened the circuit. So the needle which was in this direction deflected to this direction. Okay, needle was in this direction, deflected to this direction as soon as he start this. Okay, so this is how things was, this thing was accidental, and he discovered electric magnetism or electromagnetism. That this compass, definitely I'm going to tell you about compass, that this compass is having something. Okay, this compass, I will tell you about compass, this needle, but it will change its direction. Okay, so why this changes direction? Because this some part, okay, some part of wire which was metal before, some part of wire which was metal before, after conduction of current or electricity, so we know that after conduction of electricity, the simple metal wire is now magnet, and it is known as electromagnet. Okay, so the discovery of electromagnet or electromagnetism was not planned thing, but it was an accidental thing by Oersted. Okay, you need to remember name, only just remember this thing. Okay, so now we can use electromagnetism in various appliances like in radio, television, fiber optics. Okay, and I will tell you the uses of electromagnetic, how we can use electromagnets. Okay, so this is how he discovered things. Okay, now I'm going to tell you about some more things. So what is magnet? First of all, a magnet which can attract iron, definitely a magnet which can attract iron, everyone knows. Okay, now magnet have two properties. Okay, the two properties are when two metals are in close contact, they can attract each other. This is how both of them are going this side. Okay, force is repulsive force. In this case also force is repulsive force, we know. In this case force is force of attraction. Both of them are having attraction force, because when south and north pole come together, and in this case same north and south pole come together, so the force will be here. So this is how a magnet works. Okay, now there are two types of magnets. First magnets type of magnet is something, so it is having, magnet is having two properties, for property of attraction and property of uh, uh, making another magnet apart. So it totally depends upon how, which poles in contact. Okay, we know about this. Okay, we each and every know about this, and I think I don't need to tell you this more. Now generally we are having natural magnets. Natural magnets are, I told you, these are our natural magnets. Okay, these are natural magnets, and we can find these natural magnets in nature, and you can find this everywhere. So natural magnets means they are not electromagnets, they are just magnets, and they are provided us by nature. So these are natural magnets. They are weak and irregular in shape. What does it mean? That we have to change their shape, or sometimes they are very weak or not for our desire. Very weak, small magnet cannot attract this much higher amount of iron. Okay, because it is small. So these are our natural magnets, and we gave them shape. Okay, it was some irregular shape before, and we gave them shape, but the size is not of our requirement. Sometimes they are very tiny, or they are very small, and they cannot handle big cases. It means that if I want to pull a big amount of iron, or if I want to big amount of metal, so they cannot be used, because they are having not having much efficiency. Okay, so this is artificial magnet, bar magnet. This is bar magnet, and this is horseshoe magnet, because it is it looks like shoe of horse. Okay, it is having both poles, same properties, same repulsion, same attraction. Another type of a magnet is magnet needle. You can see this middle, this side is showing north pole, and this side is showing south pole. Remember this. So north pole is also red color, and south pole is having blue color, and it is present on this stand, so it can move. Okay, it can move, it can tilt, because it is very light in weight, and this magnet cannot move. Okay, if I put something iron nearby it, so it cannot move. Definitely it can attack, but it cannot move, that it cannot change its place. But this magnet needle is just middle over this stand, and it is very lightweight, so it can move around whenever this pole can change. This pole can come by this side by its own. Okay, it doesn't need any type of help. So this is magnet needle. Now third type of magnet is our this is our compass. So this compass is also having, this is our compass. Okay, so it is also natural, and this is magnet compass. So this magnet compass is having this magnet needle. It is same like this. Okay, it is same, this needle is same like this needle. Okay, it is very lightweight, and it can move by its own. So this red side always show north pole, and this south this blue side will always show south pole. Okay, don't get confused. And in general condition, this if there is no another source, then in general condition, if you put this needle and at any place, this pole, north pole, will show the north pole of earth. Okay, and this south pole will show the south pole of earth. Okay, so this is this compass needle in general condition is showing the poles of earth by its own. But if I want to check the polarity of this needle, or if I this magnet, or if I want to check the polarity of any another thing, then I can use this compass. So this compass is what is the difference between this and compass? That this needle is open and it is in contact with atmosphere, so it can get contact with when sometimes there is humidity or sometimes there is, you know, pollution, so it can be deflected by these other things also. But in compass is a compact thing, and it is not get affected by environment, or something is raining, because I cannot use this in rain, okay, because it is open. But I can use compass in rain because there is no problem, it is covered with glass. So this is showing north pole and this is showing south pole, so this is compass. So how compass is used? Compass can be used to identify north and south direction, okay, that one thing. Second is uh, it can also use the direction of magnetic field. I will tell you what is magnetic field. And polarity of magnet. What is polarity of magnet? If I want, I am not having any type of symbols, that which is so south pole and which is north pole, so I can use this compass, okay, so to test its polarity. So the if this north pole will get attracted to south pole definitely, and it will always uh, get attracted to south poles, because we know that north attract, north repel, north south attract, south north attract, and south repel, we know. Okay, so it will show us, okay, this needle will get attracted to south pole, so it will show south pole, and this will get attracted to north pole, so it will south pole. Okay, it is south pole. So it sometimes we are having a very huge amount of magnet, and what is mean the huge amount of magnet, that it is raw magnet. Okay, and we need to change it in these shapes, we need to change in these shapes, in these shapes. Either I want to make them bar magnet or horseshoe magnet. So this is my raw magnet, and I don't have any idea that which pole is which. So I can use this compass. So this compass is this pole is north pole, so it will always get attracted towards south pole, and this is south pole, it will always get attracted toward north pole. So this is how I can identify what is south pole and what is north pole. Okay, if you have any question or if you have any doubt, please ask me in chat box. I'm giving you 1 minute. Please ask me if you have any doubt or any question or any query regarding to this, what I have told you till now in this chapter of magnetism. No doubt. Okay, and sometimes you will be asked that why this compass is better than this. Okay, why can't we use this? Because this is no, this is just useless, this is just for laboratory, where it is not getting affected by heat and light and rain and whatever pollution, it is not get affected. But if I want to use something outside from laboratory and for better results, I have to use compass, because it is free from atmospheric pressures and atmospheric you know uh, effects. So now I'm going to another point, and this point is known as we are going to learn about magnetic field. Okay, now what is magnetic field? Magnetic field lines. Now look, magnetic field lines, I'm using a bar magnet, and I am very known of its pole. This is bar magnet, and I'm known of its poles, that which pole is this. So this is north pole and this is south pole. Now I'm aware of this. Okay, and now I'm sprinkling some iron flakes around this. I'm sprinkling some iron flakes around this. I'm just sprinkling some iron flakes around this in random fashion, in random way, in random fashion. I just did this. Okay, now just after doing this, okay, I will tilt this paper, because I am doing this in paper. I used a cardboard and I placed I used cardboard and I placed a magnet, and these are two poles, and I just put iron flakes and so many iron flakes. After that I will tilt this. What is the meaning of tilting? I will just move this, shake this very slightly, this cardboard. I will shake this cardboard very slightly, not in that much amount that all the flakes will spill out from this cardboard. No, just a very by little amount. Okay, so I just tilt it, and after some time, okay, I will place it, and I found that after some time I found that these iron flakes, okay, these iron flakes are arranged in such a manner. You can see the black, they are this black diagram, you can see they are iron flakes. So they get arranged in such a manner by their own, okay, by their own, just in such a manner like this. They will get arranged, iron flakes will get arranged in this type of manner. Okay, you can see this, and definitely some iron flakes will more iron flakes will aggregate it this side, and more iron flakes will get aggregate this side. Okay, why so? That is very simple part, because they are poles and they are having much magnetism. Both of these poles are having much magnetism, much amount of magnetism, because they are, this is a magnet and it is having magnet. So here you will find that iron flakes will attract more at these sides, at these sides, okay, these sides, okay, and the distribution is like this. So this is magnetic field lines. Okay, how to create these magnetic field lines? So for creating magnetic field lines, we are just doing an experiment, and this is very simple experiment we are going to do right now. That I am just putting this magnet in this fashion, and I'm using a compass. I'm using a compass, my compass. Okay, this is compass, and I have just used it. This is south pole, you can see easily, and this is north pole, you can see easily. So I have just used compass, and I put compass here. So definitely one thing is very clear to me, one thing which is very clear to me, that when I put compass here, this compass will show this pole, which is north pole, and the needle will move here. The needle of compass, this is north pole, and the needle will show here, the north pole will show this side. Okay, so I will make two dots. What I will do, I will make two dots of this. So I'm in this side. Here. So in this side, I will make two dots. Okay, so here I made two dots. Okay, one for north pole and one for south pole. One for north pole and one for south pole. Okay, so in north pole, I can use this arrow. I can use this arrow. Okay, now I will, and first of all, let me tell you. So this is my compass and it is showing north pole here. So I made 2 points. Okay. Now this north pole is indicating by this arrow. Okay. And south pole is indicating by this dot. So don't forget that arrow is for south pole, north pole, sorry, and dot is for south pole. Now I will move my compass. I will move my compass in such a manner that this north pole and it was south pole. So I will put this compass again. I will take this compass from this side. It was showing north pole and it was showing south pole previously. So I put my compass, I pick my compass from here, and I will put my compass in such a manner that the north pole should coincide, or it will replace the south pole. So here I will put by hands. Okay, by my hands I will use this, that it was north pole and it was south pole when I put my first position. And for second position, what I will do, I will pick my compass, and I pick my compass in such a manner that I will put my north pole over this south pole. So I will put my north pole here and my south pole is here. Okay, again I will make 2 points. This point, the direction of this needle will like this, and this is the dot which is of S part, south pole. Now I will again take my compass again. Okay, so in this case, this was north pole, or I can use, I just placed my north pole over the south pole, and again I use this south pole here. Okay, now again I'm taking my compass, and I'm taking my compass and I'm putting my compass in such a manner, that the north pole will coincide or come slightly over this previously dotted south pole, because I'm side by side I'm making dots. Okay, and the south pole is here. Okay, so again I will make dot, and again I will draw some dots. So I will keep changing the position of compass, and in each position, when it was north pole and it was south pole, so when I am using my compass again, so I will put this compass in such a manner that is north pole will slightly come over the south pole, and the south pole will take its position, and I will make point, or I will draw a arrow for north pole and draw a dot for south pole. So each and every time the needle will change its, you can see this, that how this was my south pole and I put my compass here, so I made two dots, I made this for my north pole and this for my south pole. Now I'm just putting this compass tape, and I'm placing this compass in such a manner that I'm replacing my compass, so that it was now north pole and it was south pole. Now I'm using my compass in such a manner that this north pole will come over the south pole. The pole of compass will come over the dotted, it was dotted. I took my compass from here, so this north pole will come over just slightly over the south pole, and the south pole is like here. Okay, now again I will put my compass. After making dot, okay, I make dot. This was my north pole and this was my south pole. Okay, now I will put my compass back, and I will again put like this here, and I will put this in such a manner that this north pole will slightly cover this south pole, and there is south pole. So the direction of north pole will be like this. Okay, each and every time the needle will change its direction. Okay, so there will be the direction of north and there will be direction of south. So I'm doing this all the way, and all the way the direction of south pole is like this, north pole is like this. Okay, so all the way I'm changing this thing. Okay, now here you can see the direction of here the red side is showing the direction of north pole, the red needle. Okay, here you can see the direction. Okay, how I'm changing the places of compass and residing the north pole over previously south pole. Okay, place the north pole which was having previously south pole. I'm doing just like this, and here you can see the needle, it is north pole and it is south pole, and look at the direction. Okay, look at the direction, both are in this side. Okay, both are showing two things, one is completely here and one is completely here. So after that, next part I will tell you on tomorrow about next part, and I will complete this magnetic field lines effect. Okay, but just for now, remember this thing what I have done. Okay, if you have any doubt you can ask me. So I will take your rest part on tomorrow.